Hello everyone, my name is Maya Makovsky and I am a grad student currently at Minnesota State University Mankato, and I'm studying in the Department of Anthropology and Geography. I'll be talking about my project titled Soil Carbon and Soil Health Responses to Land Use Practices Across Topographic Positions. Getting into the background of this study, southern Minnesota has very gently rolling hills or hummocky topography that formed after glacial retreat around 14 to 12,000 years ago. Historically, these uplands were dominated by extensive grasslands and lowlands such as prairie potholes that were very poorly drained and contained a lot of hydric soils. Most of this landscape has now been intentionally drained and converted to cropland. These upland soils have been degraded by decades of tillage, runoff, and erosion, while tile drainage has eliminated nearly all wetlands and aerated their hydric soils, where historically large quantities of carbon are typically stored. So we are focusing on topography because it is an important factor to consider when we are examining soil properties and soil health properties on this gently undulating landscape. This is because uplands and lowlands are dominated by different processes. So if we look at this figure here, we can see that the upland soils are dominated by runoff and erosion, where these lowland soils have lots of accumulation and run on from upslope. So all of our research sites do encompass a topo sequence, so a summit, shoulder, back slope, foot slope, toe slope, and lowland. Our lowlands do terminate into different features. So some of our lowlands are prairie potholes, some of them are floodplains, and some of them are ephemeral swales. This map here is highlighting the soil series differences. So our upland soils are non-hydric, where our lowland soils are hydric. So our topo sequence is starting in non-hydric soil and terminating in a hydric soil. For our land management selection, all of our land management sites have been consistent for 10 plus years. These farmers have not changed their land management type in that time. So we have 5 topo sequences, or 5 sites, that are under conventional cropland with corn-soybean rotation, as well as 5 long-term conservation tillage cropland sites with corn-soybean rotations as well, and mulch cover on those fields. Last but not least, we have 5 CRP enrolled former croplands. So we have conventional croplands, which are very run-of-the-mill. You will see these fields all over southern Minnesota. Then we have conservation tillage, which is kind of an intermediate conservation practice. And then we have the best conservation practice you can do on a cropland by taking it out of production. For our research approach, we really wanted to evaluate how the natural landscape or topographic position and how humans impact the land by managing it, how that impacted soil carbon storage and soil health and agricultural landscapes in southern Minnesota. So for our field methods, the soil cores were taken to a depth of 30 centimeters using a backsaver soil probe from our 15 sites, and our 15 sites are located across Blue Earth and Waseca counties in southern Minnesota, highlighted in the red here. 6 cores were taken at each topographic position from an area of approximately 10 by 10 meters. 5 of those 6 cores were combined to create a composite sample, and 1 of those cores was used for bulk density. For our laboratory methods, these soil cores were analyzed for microbial respiration via Solvita CO2 burst kits. We sent our samples away to Ward Laboratories in Kearney, Nebraska, where they analyze our soils for organic matter via loss on ignition. We also analyze our soil for bulk density using a modified core method from that core we set aside when we were taking our samples, as well as aggregate stability via the SLAKES app. We calculate organic carbon stock by multiplying organic matter by 0.58, multiplying that value by bulk density, and multiplying that by our depth of 30 centimeters. We conducted a NOVA in our studio to assess differences in soil properties. So leading us into our results, we separate it by land management and topographic position. So land management first. Here we have our carbon stock. So the calculated organic carbon stock were not statistically significant across the land management types, and this is because the two variables used to calculate organic carbon stock, organic matter, and bulk density, were also not significantly different. Here we have mean microbial respiration. So we see that CRP is greater than both conventional and no-till croplands. Here is the aggregate stability index. We see that CRP is also greater, or has greater mean aggregate stability index than conventional and no-till croplands. Into topographic position, once again we have the carbon stock here. We see that the lowland position is greater than the summit, shoulder, and back slope, so our uplands, as well as the two variables used to calculate organic carbon stock, organic matter content, and bulk density were also significantly different. However, aggregate stability and microbial respiration were not statistically significant across topographic positions. So our main takeaways here are that topographic position has significant impact on soil organic carbon, organic matter content, and bulk density, and it is important to consider when we are assessing soil health. Lowland soils do store the most organic carbon, while shoulders and back slopes, our most erosive positions, store the least regardless of land management. So that's a pretty important finding that we should consider when we're talking about conservation practices. Focusing on those shoulders and back slopes may be very beneficial. For land management, CRP grasslands do have greater soil microbial respiration and aggregate stability than conventional cropland and conservation tillage cropland sites. So land management does play a factor in soil health. Further research is necessary to understand why the organic carbon stock variability by land management is different. So the lowlands at each site, like I said before, they terminate in different features. So I feel like it'd be super important for us to understand what hydrology, what the different hydrology of these lowland types and features would do to soil health and soil organic carbon stock. Research is ongoing to directly measure organic carbon content using an elemental analyzer to more accurately calculate organic carbon stock. So we will directly measure organic carbon stock versus taking organic carbon from the organic matter value. I'd like to acknowledge that this research is funded by the James Goff Field Studies Award, as well as the Mankato Graduate Student Research Grant. I'd like to give a special thank you to the landowners for allowing me access to these sites, and for my student peers for assisting me with fieldwork and laboratory analysis.